In question 9, we are being asked to factor this expression. The first thing we need to do when we factor is look for common factors. 6 and 24, they can both be divided by 6. So I'm going to take 6 as a common factor. I look for the variables. Here I have x squared and here I have y squared. There's nothing common about them. So my only common factor is 6. I open parentheses and I'm going to see what's left in each term. 6 divided by 6 gives us 1 x squared, or just x squared. Negative 24 divided by 6 gives us negative 4. And I don't forget to put my y squared. I'm not done because whenever I'm being asked to factor, I have to factor completely. Factor completely means I need to look for what I have between parentheses and I need to make sure that it cannot be factored further. We have here two terms. One is positive and the other is negative. This is a perfect square and this is a perfect square as well. So this is a difference of two squares which can be brought back to being two conjugates. So I open two parentheses. I'm going to use the difference of two squares method. I'm going to open two parentheses. I'm not going to forget to bring down the 6 as it is. The two parentheses, one of them will have a positive sign and the other will have a negative sign. I'm going to ask myself, what gives us x squared? What multiplied by itself gives us x squared? And the answer is x multiplied by x. So I'm going to put here an x and here an x. Now I'm going to ask myself, what multiplied by itself gives us 4y squared? And the answer is 2y multiplied by 2y gives us 4y squared. So I'm going to put here positive 2y and here negative 2y, because positive 2y multiplied by negative 2y will give us negative 4y squared. I make sure that whatever I have between parentheses is already in its most factored form, which is true, and that's going to be my final answer.